What else could I talk about? I mean, there were a lot of comments on that video. Lots of things to say. Well, I could do this. I could talk about cast iron, similar to how it's a work hardened, similar to how it can't be work hardened, or how that's not a good thing. And the same reason as to why it's very bad with work hardening. You can't really weld it that easily. Yes, it can be welded. Duh, almost anything can be welded. But cast iron is difficult to weld, especially if you don't have much money, you don't have many tools, you don't have much experience, for the same reason that work hardening would be a very, very bad thing. All the carbon that's in it, all that carbon that settles out of solution as pure graphite. Contrary to apparently common thought and belief, cast iron is not just iron that has been cast. It is not pure iron. It is not mild steel. It is not steel. It is, you have iron. You have not really wrought iron. Wrought iron can cover a ton of different things. It just means that it's been wrought, been forged, it's been made by hand. Wrought iron can have low carbon, it can have higher carbon, it can harden, it can not harden, it can have a ton of inclusions or impurities. Wrought iron's different. Cast iron is not, you have iron, mild steel, low carbon, medium carbon, high carbon, and then eventually cast iron. And then beyond that even you have pig iron, okay? But pig iron is really a certain classification of cast iron where it has above a certain percentage of carbon and is used in a particular process. Just look it up what pig iron means and how it got its name. But cast iron has at least 2% carbon content. That means that it has way more carbon content than your typical tool steel or hardenable alloy. You'd think, oh, well, I guess it's extra hardenable. No. No, no, no. It has so much carbon in it that the iron grain, the iron crystals, cannot contain that carbon. Iron hardens by the carbon basically getting into the crystal structure of the iron and replacing iron atoms within that crystal structure. Going from body-centered cubic to face-centered cubic and back and forth, different stuff like that. I'm not going to get into that because I'm not an expert on that, but I can tell you that because of that, you have carbon that is outside of solution or in perlite, in just unhardened steel, and then in hardened steel, in martensite, you have carbon within the iron crystal structure. If you have excess carbon, that carbon is now again outside of the crystal structure, and no matter how hard you get the iron crystals, you have soft graphite inclusions from the additional carbon. This can be remedied in certain ways, such as the inclusion of a nodularizing element, which causes those graphite flakes to form into spherical graphite nodules, which distribute stress evenly. Otherwise, you get graphite inclusions that are flakes, and they can break very easily, they shear very easily, much like pencil lead or pure mineral graphite, and a crack can propagate from right here all the way through over here in the blink of an eye. You just start to get a crack and then add any more stress and it breaks. If you want an example of that, go watch the either Crushing an Anvil or Crushing a Vice by the Hydraulic Press channel. Okay? Go watch the hydraulic press. Crush a Vice. That's a horrible accent. The hydraulic press channel did a video where they crushed a cast iron vise. And it took stress, and then once it broke, crack propagated from one side all the way to the other, and it shattered. Mild steel would not do that. Even a tool steel would not necessarily do that. Cast iron will. Ductile cast iron has those nodularizing elements in it, such as magnesium. Just a little bit of magnesium added to it, and suddenly it can be heat treated. It can be hardened. It can be tough and durable and used as a very effective anvil. That's not ductile iron. It's an anvil. My anvil's still outside. It's over there. So I'm talking about a different cast iron tool, which is this vise. Graphite inclusions are not a good thing, but ductile iron works around it using chemistry and metallurgy. But this is not ductile iron. The Harbor Freight Anvil is not ductile iron. It is gray cast iron. I know that for a fact. And that same carbon causes problems with welding. First of all, really high carbon alloys and high alloy steels are difficult to weld. They harden. And when you heat something up rapidly in a very localized spot, and then it's a large enough object that it sucks that heat out quickly, it hardens. It's hot enough that it's past the critical point, it's past its critical temperature, and then it cools so rapidly because it's a heat sink that it hardens. That's a problem. So you need to preheat the object so that it won't steal so much heat from it, and you need to reheat it so that you can de-stress it and basically temper it so it won't crack and it won't fracture. Cast iron even more so, because if you get any stress from that process, it's additional stress, just like work hardening, that will cause problems and failures in cast iron, meaning that your weld will fail. Your steel plate that you just welded to your anvil will just pop off. That's not a good thing. So yeah, I could just weld a steel plate to the anvil, right? Yeah, you could. But do you have a welder? I have a welder, but it's a 110 volt welder, and it welds 1/8 inch steel. That's not good enough. I have 110 volt power. I do not have 220. Meaning I can't even buy a welder to support welding something of that thickness, because I don't have a power source that works with it. Not to mention, that power source is irrelevant if I can't afford the welder. A $300-400 welder, even a $1,000 welder, if I already have that much money invested in a welder, I'm not going to be buying a $50 tool and then modifying it because it doesn't perform like it needs to. What I'm going to be doing instead is I'm going to either be buying an actual legitimate expensive tool, or I'm going to be buying materials that are worthwhile as an anvil and then welding it myself. Like seriously, why would I buy a $55 anvil, $60 anvil, and then weld up a simple stand if I had a welder that can weld 3-inch thick material? In that case, I might as well just buy thick plates of steel, weld it to a stand instead of bolting it down, and welding a really solid stand instead of what I did. But I don't have that ability. This is like 1/8 inch thick. That's the max I can really weld. Maybe 3/16, but try making an anvil out of 3/16 stock. It's not going to work very well. So yes, you can weld to the surface of an anvil, to the surface of a cast iron anvil, but I don't think it's worth it, because the amount of cost that goes into it, the amount of time, the amount of energy, the tooling required, the infrastructure required to support that tooling, it's just not worth the cost when you could just buy a better tool. You know, I had to realize that as a knife owner, not just a knife maker, but a knife owner. Why buy a knife and then modify it? Why buy a car and then modify it? Why not just buy the thing I want in the first place? The thing that will do what I need it to do in the first place, instead of buying something that's kind of there and then requiring modifications to finish it. Just do it right the first time. Side note, no, this is not a Harbor Freight Anvil. It's an unfortunate side effect of the same paint color. But this is an Irwin. It's not much better than a Harbor Freight. I honestly wish I had bought the standard vise instead of the rotating jaw vise, because as a blacksmith you may end up having to hammer on these jaws, and this thing does not hold it perfectly tightly, and so it will slightly rotate as you hammer on it. That's not a good thing. At least not for a blacksmith, not for a heavy duty metal worker. So if you're looking at a vise, I do not recommend the rotating jaw vise for a blacksmith or a metal worker. It has its place, but not for a really heavy use. Anyway, cast iron. Not a good anvil material. Yes, you can modify it. Yes, you can weld on it. But a lot of people also just take it to someone, have them weld it. Okay. Again, similar to when you suggest, just go get a stump. What are you, an idiot, making a metal stand? Just go get a freaking stump, you stupid asshole. Well, yeah, I could do that. I'm not an asshole for not doing it. I'm not an idiot for not doing it. There are reasons I did this. There's a reason I did it for my cast iron anvil. Okay? There's a reason that's on a metal stand. Look around here. You see those trees? Do you see what those trees are made of? They're not big stumps. They're not incredibly tall. And do you see any other trees around here? Not really. I don't live in a place with a lot of trees, so where am I going to get a tree? Where am I going to get a stump? And if I do get a stump, how am I going to process it down? How am I going to cut it? Do I have a chainsaw? Well, I do now, but I don't have a chainsaw with a bar long enough and a chain long enough to cut through a 2-foot stump. At least I'd have to go around it with the chainsaw, and then I'd have to clean it up afterward. But that's a tool that I'm not necessarily going to have, that is expensive to purchase. The bar and chain is going to be at least $50 or $60 to have one long enough to cut through a stump in one go. And where the hell am I going to get it? It's not going to be free. I'm still going to have to pay for it. They may cut it for me, but they may not cut it straight, so I may have to cut it again. I'll have to get excess. I'll have to transport it. There's a lot of cost involved in getting a stump. Hidden costs. If you don't have the tool to do something, you have to buy the tool in order to be able to do it. So it's not just the cost of your time and the materials. You also have to factor in the cost of the tools. Well, you could just take it to somebody and have them weld a plate onto the surface of the anvil. Oh, yeah, okay. So am I going to provide the material, or are they going to find the material? How much is that going to cost? Shop rate, I think, is generally about $100 an hour for a welding shop or a fabrication shop. So let's factor in $100 for fabrication shop hour, because they're not going to charge less than an hour for a shop. And then they have to be able to preheat the anvil. They have to be able to preheat the anvil. They have to be able to weld the plate on. It has to have the hole cut in it for the hardy hole. Overall, you're talking about at least $100 for the service, and then materials, possibly even more time because they have to preheat it and then reheat it because it's cast iron. It's not just a simple, straightforward process to weld a plate onto the anvil. It's really not. There's hidden costs there. So you're talking about at least $150, potentially at least $150, to have a plate welded onto a $60 anvil. That puts the anvil over $200 for an anvil which overall is still made out of cast iron. The horn is still cast iron. You can't use that. It's too soft. And it's an unsupported part of the anvil. It can break. Do you know what the most common part of the anvil is to break on those Harbor Freight ones? The feet. The mounting portion of the anvil. The one that attaches it to a stand or a stump or whatever. If this breaks, well, you're losing stability. You're losing attachment method. You're losing functionality of the anvil. What are you going to do? Take it back to them and have them weld it back on? That's going to cost again. Now, if the horn breaks, you just have a hornless anvil. Cool. That's wonderful. And you could just weld plates onto the on the horn, but are you going to weld it on the top? You're going to weld it on the sides? You're going to weld it all the way around? Are you going to cut it off and weld the horn back on? Are you going to just grind down the entire horn and then sheathe it and weld that on? How are you going to do that? That's really expensive. And when you're trying to tell me a $50 or $60 anvil does not compare to a $300 anvil, and yet you're talking about welding a plate onto the face. You're talking about not fixing other major parts of the anvil and still having durability issues with those other parts and with the main part that breaks. Yeah, it does compare favorably to a $60 anvil. A $300 anvil to a $60 anvil. Yes. But apparently you also didn't read the description, because I also said a good option is a block of mild steel or a railroad rail. I personally wouldn't recommend a railroad rail because this took a long time to grind and profile. Okay, this was a pain in the ass. Cutting this out, oh my gosh. I hate working on this thing. But I'm happy I did it at this point. It's taken a long time, but it's pretty good. Still don't have a hardy hole, as you can see. That's the main reason I bought the cast iron anvil. I did not buy it to use it as a main anvil. I did not buy it as a main forging anvil. I bought it as a striking anvil and as a hardy tool. So I could make hardy tools so that I could make hammers and other things and actually punch holes through the workpiece and through a hole in the anvil, which I can't do on this one. That's why I bought it. And then I figured, you know what, I'm going to test it. So I did. And I found that it was not nearly durable enough to consider as a main forging anvil. I'm still going to keep it. Not going to throw it out. I modified it so I can't return it. At least I can't morally return it. But I'm also not going to weld anything to it because that's an unnecessary and unproductive modification that it's just not worth it. Cast iron tools are not worth that level of modification. They're not. Just get a better tool. And that's why I recommended the NC Tools standard anvil from Centaur Forge. Since then they've gone up. They're about $300 now instead of $260 before $15 shipping. So they are going up in price. Keep that in mind. But they are a much, much better tool than that one.